So the first one, we're going to state the transformations in the correct order. So you start with the inside. Reflections are first. So that negative comes first. That would be reflection over what? It is y, because it is on the inside. But that bothers you guys way more than me. I'm happy if you are awake and talking to me. Also, the negatives are like the most commonly messed up things. So, you know, reflect y-axis. Then what is this going to do? We're still inside. Left 5, good. Then the stuff on the outside, that's the 3 and the 7. Which one would we do first? 3. So that is vertical stretch by 3. So it's going to be 3 times as tall. Do you remember I had the little slinky out here when I taught this way back in August? I would like stretch it. All right, and then the last thing, down 7. Again, it'll be multi-choice. All right, this one you're not going to actually graph. We're just going to make a table of values for the transformed function. First, you want to make a table of values for the one that you're looking at. And so we're going to use these 5 points. So let's just make a table for what we're looking at. And so those points, I do left to right just to stay organized. You'd have -2, 0, 0, 2, 2, 0. What is that? 4, -2, and 5, 0. I put a lot of zeros in there because 0 is an easy number to work with. So now we're going to make a table for how it got transformed. Let's do the inside stuff first. And remember, it's kind of backwards. All right. So when you look in here, do you see how there's a 1/3? It's actually going to be 3. Good. So 3x. And do you see how this is a -1? It's going to be +1. That's because it moves you to the right. So just try to remember the inside stuff is backwards. Backwards. There's only one thing on the outside of the function, which is what? Like, what's the only thing on the outside? A negative. So it's just going to be -y. So all your y values are just going to negate. So actually, let's do those first. I always go for the easiest thing first. If you just negate all of these y values, it'll be 0, -2, 0, +2, 0. You can't negate a 0 because it's 0. Now, all the other ones, you're going to multiply them by 3 and add 1. Basically, you're plugging them into this, all right? So if you plug in -2, -2 times 3, -6 + 1, -5, good. And then if you plug in 0, you're going to just get 1. If you plug in 2, it'll be 6 + 1, which is 7. If you plug in 4, that'll be what? 12 + 1, 13. And then if you plug in 5, 15 + 1, which is 16. All right, so looking at number 3, writing the equation. The first thing you're going to need to find is the slope. So do you remember, like back from Algebra 1 or back when we went over it in August, how do you get the slope from 2 points? 1. That's going to go in the denominator. 2 minus y1. Good. Okay. So y2 minus y1, you're going to do 8 minus 7. And then in the denominator, now there's a bunch of negatives. -5. Oh, good. Why is it going to be +1? Yeah, negative. Minus a -1. Okay, good. So 8 minus 7 is 1. Denominator, -4. Good. Now you have to pick a point. I always say pick the first one for no other reason than it's the first one. And it's going to be y minus which one of the numbers? Good, y7. It's the y. Okay, y minus 7 equals, I tell my Algebra 1 students, this is like you have all the ingredients, you're just putting it into the recipe. You're just putting it in the right spot. All right, equals which number? -1/4. That's your slope. Parentheses. And then it's x minus -1, which will actually be x plus 1. Bless you. All right, so that's your point slope form. To get it into slope intercept form, you're going to do 2 things. We're going to distribute and then get the y by itself. So if you distribute the -1/4, you get -1/4 x, and then -1/4 times 1 is -1/4. Good. And then you have to add 7. Don't write +7 + 7. You need for it to be fourths. So the $1 million question is, how many fourths is good? Perfect, 28. You guys are good with the fractions. Awesome. All right, so it would be y equals -1/4 x. And then if you add those together, -1 plus 28, 27 fourths. Okay, using the graph to the right, state the parent function. All right, what kind of function is this? Yeah, absolute value. The transformations, and then write a function. All right, so typically that center point is at 0, 0. So using words like up, down, left, right, how did it get shifted? Good, left 4 and up 2. Good, left 4, up 2. And do you see how it's stretched out? It's a vertical stretch by how much? Good is 3. Like 3 is the answer. How did you get 3? Like you count the little boxes. Do you see that? How it goes up 3 over 1? Slope is 3. 1, 2, 3 over 1. Like, yes? Okay. Vertical stretch by 3. And so what you're going to do is put all that information together into an equation. So put f of x equals, and then what? Like just put it all together. Like what number is going to go where? Perfect. 3. And then you need an absolute value because we said it was absolute value. What's going to go inside there for the left 4? Oh, x plus 4. And then up to plus 2. Cool. That one's not bad. Yeah, that one was good. All right. Is this even or odd? You're going to plug in -x, the opposite of x, and you don't try to force it to be anything. You just see what happens. If it comes out the exact same, it's even. Opposite is odd. Do you remember odd, opposite? That's kind of a convenient way to remember it. So -x to the third, that means -x times -x times -x to the third. Good, you don't lose that part. So -x to the third. -4 times -x will be +4. Good, because negatives cancel. Then you compare. Is this the exact same or the exact opposite? Is it? Oh yeah, exact opposite. So odd. Same would be even, opposite is odd. What if you get a mixture? Then it's neither. Okay. What are the x and y intercepts? Let's do the y-intercept first because it's a little easier. Again, I always do the easiest thing first. You're just going to plug in 0. So let's see what we get. 0 minus 1. -1. But it's going to be -1. So +1. Square root of 1 is 1. Good. -5. -4. The x-intercepts are a little harder because you have to set the whole thing equal to 0 and then solve it. But you guys are good at solving equations and I just believe in you, okay? What would you do to both sides to start solving that? +5, good. Algebra is just moving stuff. Just move the 5 to the other side. All right, then what? Good, square both sides. Gets rid of the square root. 5 squared, 25. And then you want to distribute the negative. Okay, you could just divide the negative to the other side. You want to do that? I think that's easier because watch. Look, don't look away. Watch. This is how you move a negative to the other side. You could distribute it though. If you said distribute, that's not wrong. You'll just have like one extra step. All right. And then last step is +1. So you get -24. Comma 0. All right, then we did piecewise functions. All you have to do is make a decision where -1 lives. Is -1 smaller than 1 or bigger than 1? Good, smaller. So you're going to plug into the first piece of the function. You don't even need this at all. All right, you just make a decision. And then you plug it in. -1 plus 1. 0 squared is 0 plus 3. 3 is your answer. But you have to make a decision. All right, state the X values where we are discontinuous, removable or non-removable. All right, there's two of them. Where X equals what is a discontinuity? Good, -3. See who remembers this. Removable or non-removable? Why is that removable? You just like removed a point. All right, where's the other one? 3. Yep, good. 3. There's a vertical asymptote there, so non-removable. You can't fix it just by putting a point back in. It's a bigger problem. All right, we're going to look at this graph. Maximum, minimum, increasing, decreasing. All right, where is the relative maximum? And remember, you have to write it such and such at X equals such and such. So maximum would be this one. You want to say 2.5? All right, so maximum is 2.5 at X equals -2. That's our relative maximum. I'm just going to write them next to the word, so I don't have to label them all. All right, minimum. Relative minimum is this point right here. -4.5 at X equals 3. That's our minimum. And you know what? I'll label the increasing and decreasing over here because I'm going to run out of space. You have to read left to right. So it goes -infinity to +infinity. Okay, left to right. So just reading left to right. Here, I'll point at it. What's the graph doing? Good. So we increase from -infinity until -2. Good. And then we decrease from -2 to where? 3. Perfect. And then we increase again. So we're going to put union. Perfect. All right, number 10. Oh, I remember when you guys took this test, you guys all nailed this. And I think this is pretty hard. I remember you guys did great with this. We're going to write the equation. I think it's easiest to decide where the split happens first. Oh, do you remember the flip book we did?
Yes.
You cut it apart? No. Wait, yes. Did you hear how like 1 second went? No. Wait, yes. I kind of like reviewing because it's like we walk down memory lane. Remember all the things we did together, guys? All right, where does this one split? Like if you were cutting it, where's the cut point? 1. All right, so for this, we have less than or equal to 1. And why did I put the equal to on that? Closed circle. And then the other part is greater than 1. Do not overthink the equation for this part. What is your equation for this part? -2. Thank you. Constant at -2. Now, the other one's a little tougher. It's going to be quadratic. Good, so perfect. There has to be a squared. It looks like it went right 2 and up 2. Okay, so it'll be x minus 2 squared. And then what on the outside? Plus 2. And you have to look at the center. I know that's weird. And actually, I didn't leave space for it, but there's one more thing I need to put in the front of that. What do I need to put in front of that? Why do I need a negative? Yeah, upside down, reflected over x. Again, you won't have to build that yourself on the actual test, though. You're just going to have to pick the right answer. All right, this one actually involves work. In vertex form and state the vertex. You're going to factor out 3, but only from the first 2. This is complete the square. So if you factor 3 out of just the first 2, you're going to get x squared plus 24 divided by 3, 8x. Cool. I'm going to use another color. It's not going to show up, but I'm going to try. Divide by 2 and square. So what is 8 divided by 2? 4 squared, 16. Now, it is not actually a 16. It is a 3 times 16, 48. How do you turn a 48 back into a 43? Because you're not allowed to change the problem. -5. Hold on, that went really fast. So can I recap that? Because I think I probably lost half of you. 8 divided by 2 is 4, squared is 16. Good to there? It's actually 3 times 16, which is 48. 48 minus 5 gives you 43. All right, and then you have to write it as blank squared. And then what goes in the blank? X plus 4. Good. It also says to state the vertex. The whole point is that you can now see the shifts. Using words like up, down, left, right. How did it move? Left 4, down 5. So your vertex is -4, -5. And went left 4 and down 5. And I just broke this fence. All right, find the zeros by factoring. Draw your 2 sets of parentheses. Now, 12 can split a bunch of different ways. If we guess wrong, we will just do what? Try again. All right. You want to do 2 and 6 or 3 and 4? It's probably not 1 and 12.
4.
Okay. Don't sit there and not try anything. You know, you got to try something. All right. Then 3 is going to have to be 1 and 3. 1 and then 3. Okay, let's see if it works. If it didn't, it's not a biggie. All right, we'll just try again. What do the outsides give you? 12. Insides 3. 12 plus 3 is not 16. Okay, so let's try again. We'll try 6 and 2. You know, I kind of like when we guess wrong and then fix it, because then I get to model for you how that works. Like, here's how you guess and check. All right, now I think we'll put the 3 here and the 1 here. See if I'm right. Because the insides will give us what? 18. I want that to be a positive 18. And then -1 times 2. So 18 minus 2 will give us 16. Yay! All right. And then your answers, you would set those equal to 0. If you want to show the steps, that's fine. I try to encourage pre-calc students to kind of jump to the answer. What would this one give you? 1/6. Oh, this one, yep, you had it just written the other way. 1/6, and then perfect. And well said. Usually people say -3/2. Halves is how you say that. Oh, I like these ones. This is getting into the polynomials. For leading coefficient positive or negative, you look at the right side. So is the right side going up or down? Down. So we would say negative. Even or odd? The ends are going the same way. Do you remember what that means? Even. Odd is opposite, which is convenient. Least possible degree. You take the number of turns and add 1. So good. 1, 2, 3 turns, you would add 4. Now listen, if you said this was even, this needs to be an even number. Okay? Question? Are you okay? All right. And then the number of real zeros. Look, you have to watch me point because I don't have a better answer than, hey, look. You see how there's 1 here? 1 here, and this one counts as 2 because it's bounced. So a total of 4. I didn't do that. It gets more complicated there, so we don't do that. Okay. This is your synthetic division. I'm telling you, one of the zeros is -1/3. Do you remember that's how they did it on the delta math? Like they gave you 1 to get you started so you wouldn't need a calculator. Okay. Is our countdown in order? I think it is. And hey guys, what is the remainder going to be? Great. You know the answer before you do the problem. So bring down the 3. Here we go. -1/3 times 3 is -1. The 3's cancel, it's negative. Oh, and then what do you get from that column? 0. Bless you. -1/3 times 0 is 0. So 48. Now, even if you didn't know what 1/3 of 48 was, it's going to be, yeah, -16 because that has to come out to 0. So then you put the x's back in. It's going to be 3 x squared, focus, plus no x's. So I just wouldn't even write that. Plus 48 equals 0. And then you just solve. Like, just keep going. Just keep going. What would you do to start solving that? Yeah, -48. I ran out of space. I'm gonna have to come over here. Not yet, but divide by 3. That'll give you x squared equals negative 16. And then yes, square root. Now, what do you put when there's a square root? Plus or minus. Oh, why is it I? Because it's negative. You guys are gonna rock this. It's gonna be awesome. Be all good. All right, what is the equation? Go ahead and put f of x equals. Now you read it right to left, which is a little weird. The right side is going down, so you need a negative. All right, so here's our first 0. Do you see how it's at 2? That means our factor is going to be good. And then what's the power on it? 3, because it wiggles. All right, and then here's the next one. It's at -1, so our factor is +1. It's crossing straight through, which means a power of 1, and you just wouldn't write it. And then what's the last one? So x +4, good, because it bounces. I love those two. That's just pattern finding. You guys seem like you're doing okay, so I'm going to just keep going. I'm going to get this part done with. I'm going to get the boring part done with so we can do the fun part. All right, write the equation of a polynomial with these zeros. X equals -2, so that would be x plus 2. And it says to the third, multiplicity of 3. That's this thing. Do you remember this? Pascal's triangle. Good job, Pascal's triangle. You know what I did have a couple of people do on the test, though? They just wrote x plus 2, x plus 2, x plus 2, and then, like, distributed everything, which was, like, not the point of what you were learning. These are your coefficients, 1, 3, 3, 1. And this is just pattern finding too. The first one's going to be x to the third, and then the next one, x to the second, x to the first, x to the nothing. And then do you remember the next part? It would be parentheses 2 to the nothing, good, to the 0, and then 2 to the first, 2 to the second, 2 to the third, and then just add it all together. Yeah, and then you can just get rid of anything that has a 0. I like to write them because it's part of the pattern, but they are just going to go away. So you get x cubed plus, let's see, what would that be? Good, 6x squared. No, 2 squared is 4, times 3 is 12, so 12x. And then 2 cubed is 8. Good. Right, so first thing you're going to have to do is factor this. So go ahead and draw your 2 sets of parentheses. Actually, you can do that for both of them. And so how is the numerator going to split up? Okay, good. We got x's. What else? 3 and 1. Good, thank you. Plus 3 minus 1. Now, as a foreshadowing, one of the ones in the denominator is probably one of those. Okay, so this will be perfect. Now, because this cancels, what does that mean we have? A whole. I don't think I asked that on this one, though. No, I didn't. Okay, so domain. Yes, we do. Do you want to do that first? All right, that would be at -7. Oh, x equals -7. So let's go back and get the domain. You do still have 2 troublemakers. Who are the 2 troublemakers? Good. So we are going to skip over -7 and 1. One of them's the whole and one of them's the vertical asymptote. I just didn't ask you about the whole in this question. So the -7 was the vertical asymptote. All right, and then intercepts. So x-intercept is going to be something, comma, 0. You just set the whole thing equal to 0. You start solving that, you would multiply over the x plus 7. Are you coming with me there? But what is anything times 0? 0. So really all you have is x plus 3 equals 0. So -3. Good. And then y-intercept, how do you get that? Perfect. Oh my gosh, you guys rock. You can look at the factored version or the original. It really doesn't matter. I just cover up the x's. If they're 0, they're gone. So do you see how it's just 3/7? Like that's just literally what's left. We're going to do the same thing for 18. It's the exact same thing, but I asked you for different stuff. Good. It's the one that didn't cancel out. So this one would give you the whole. The one that didn't cancel out gives you the vertical asymptote. Correct. Correct. All right, so go ahead and draw your parentheses for this one. Yeah, go.
One of those, like in the original problem, where it has 3/7, is it always going to be like that?
Yeah, well, -3 over -7 and the negatives cancel. Yeah, I just cover up the x's because if it's 0, they're gone. Yep. Yeah, the original one or the factored one, doesn't matter. Won't make a difference. All right, this is a more difficult factoring problem. It's going to be 3x and 1x. So maybe actually let's do the denominator first. Because you know one of the things is going to match. Do you get what I'm saying? Like do the easier one first because something's going to match. So look at the denominator. 8 is going to split. Good. +4, -2. So now when I look back at the numerator, 2 can only split 1 and 2. So I know it's going to have to go like that. Like I'm going to have an x minus 2 in there. Do you get what I'm saying? Like do the easier one first and then it'll help you with the harder one. So that'll be a -2. Outsides will give you -6x and then +1 will give you -5. All right, so state the whole. What is going to be the x value for the whole? Good. So it'll be 2 comma, how do you get the other? Plug in 2. Oh my gosh, you're going to destroy this midterm. All right, plug in 2. 3 times 2 is 6, plus 1 is 7. And then 2 plus 4 is 6. 7, 6 does not reduce, so just leave it. All right, what else did I ask you about? The reason I did this is because, do you remember how the horizontal asymptote is the end behavior? They're the same number, okay? So your horizontal asymptote is y equals, now you do kind of need to look at the original one for this. You compare the powers. Do you see how they're both squared? Good. It would be 3/1, which is just 3. I'm not going to write the end behaviors. They're 3. Do you get what I'm saying? That's why I put them both in the same problem. It's the same answer, all right? And then the range. You are going to have to skip over the horizontal asymptote and the y part of the whole. So which one's the smaller number? Which one comes first? Yeah, good. So we're going to skip over 7, 6, and 3. That's why I put all those things in the same problem, is because they're all really like kind of the same answer. Like once you do one of them, then you have the other ones. All right, focus. We only have a couple more to do, guys. All right. So if you were to factor this, spoiler alert, it's going to come out to x minus 4x plus 3. Are you with me there? Yeah. Trying to save you some writing. So you would multiply x minus 4, x plus 3 to each of these. If you don't want to write it 3 times, fine. If you can do it in your head, I say write it so you can see what cancels and what's still there. I kind of had to shove it in there and write sort of small, but that's mathematically what you're doing, is you're multiplying that to each of them. With the point being, like, why are we doing this? The point is that the fractions are going to cancel. That's why you do them. So what cancels in the first one? Good. And then you can see what's left. You have to distribute this x. Good. See, then you can see that x squared plus 3x. For the second one, yeah, now careful. You're distributing, yeah, good. You're distributing a -2, so good. It'll be minus 2x plus 8. And then the last one's really nice because what happens is the whole thing cancels. You just get 14. You know what this reminds me of? Do you remember the clue around the room thing that we did? I think it was over there. Like that one? Okay. Like terms, 3x minus 2x is just 1x. And I call this evacuate. you subtract over the 14 so that it all equals 0. So 8 minus 14 be -6. And then factor it. Good. So that would be x plus 3, x minus 2. And so what are your two potential answers? Good. Now, do you get to keep them both? Get rid of them both? Get rid of one, keep the other? Good. Why? Yep, it's your troublemaker. So this is your only answer. All right, the inequalities were the number lines. Remember your pluses and minuses, negatives and positives? How is your numerator gonna split? It would be x and x. How would 18 split? It would be 9 and 2. You would need, good. And then you also have the x plus 4 there. Yeah, 18 is 9 times 2. Well, and then to get 7 in the middle, it's plus 9 minus 2. That's how you get your symbol. Just instead of writing it side by side, I just went ahead and wrote them so I can do the number lines. All right, and then which one gives you the smallest 0? Because you have to go left to right. Yeah, this one would be -9, and then -4, and then +2. And if nothing weird happened, they're negative and then they turn positive, which is how I made it on there. Like that's how it'll be. And then you can slice up your number line. Are you remembering this? This wasn't too long ago. We're going through chronologically, so we're getting closer and closer to like the current stuff. You draw in your little balloon strings, and then you get the overall symbol. So the first section, negative times negative times negative, is negative. And then here the negatives cancel, so positive. I mean, they're going to alternate. And then it's which section do you want to be your answer? Usually the number line part goes well. It's what's your answer that's for some reason the difficult part. Why is it the negatives? Because that's correct. Less, perfect. Oh my gosh, you guys are awesome. So we want this section. I'm coloring in the part I want. And this section. So it'll be negative infinity to where? -9, good. Union, -4 to 2. This is your final answer. Why did I use parentheses and not brackets? Doesn't have an equal to. All right, and then the last page is the stuff you literally just took a test on and did well on. So let's just practice it again. All right, 21. Using those functions, f of g of -2. Which function do you start with? F, good. F of -2. Look at -2 cubed be -8. -5 times -2 is +10. And then +1. So what is that going to be? 3? That gets passed along like the telephone game. And now we're doing g of 3. So we plugged in -2 to f. We got 3 as the output. Now we're going to plug that into function g. So that would be -3 minus 3. It's good. Perfect. Thank you for not saying 0. I appreciate you so much. All right, here you're not going to get a numeric answer because there's an x. All right, this gets plugged in to the other function. G gets plugged into f. So you're going to have -3 times. Now don't write x plus 1 squared. Just write it twice. +2 x plus 1 minus 8. For the sake of time today, can I leave that? You guys are good at that. You're good at distributing. I feel like you'd be okay there. Are you all right? Like, I think you guys could just do that. I'm going to leave that. I'll fill it in when I take the picture, but I think you guys can do that. I don't want to waste your time. I want to get to the game. All right. Using these functions, find the domain. Who's your troublemaker on this one? 3. Leave out 3. And then this one, -4 to infinity. That's like you have to be this tall to ride the ride. You need to be -4 and above. This is your whole vegetarian thing. Does G have a restriction? Yes, that means what? Keep it. Fantastic. We remembered things from last class. Does f have a restriction? Yes, that's a problem. G of x, you better not equal 3, better not be 3, or else no dessert. All right. So you're going to take your g of x, say, hey, you can't be 3, and then work it out. Don't equal 3. We're going to have problems. All right. What would you do to both sides? Square it. 3 squared is 9. Subtract 4. You can't equal 5. But also, don't forget to keep this one. So you want to skip over 5, but also you have to stay above -4. So it's going to look like this. Shush. All right. Find the inverse. That means you're going to switch x and y. It'll be x equals 1/7 y plus 6 squared. Heads up. Eventually, you are going to square root, and you cannot put plus and minus. You have to pick one. Are you going to pick the plus, or are you going to pick the minus? Read the rest of the problem.
Oh, that might.
Why are you going to pick the minus? Because it says to. I gave you the one with the negative infinity. You see that there? If it has a positive infinity, you would do positive one, okay? So eventually when you square root, you're going to do the negative square root. But we're not doing that yet. How do you cancel out the 7s? Times 7. And then here's where we square root. Do the negative square root. And then your last step is subtract the 6. I keep saying it's multiple choice. You know how it's a negative square root on this one? Do you understand that probably bless you, probably 2 of the answers have a negative and 2 of them have a positive? Like you'll be able to narrow it down to 50-50 just from looking at the answers. All right, and then here's the difference quotient. We'll work this one the whole way out. What was step 1? Plug in x plus h. Oh, do you want to, oh, good. Because I was going to see if anybody said that because I like being able to skip that step to save you some writing. X plus h squared, x squared plus, oh my gosh, perfect. You remember that, it saves you some writing, which this is already a lot of writing. All right, minus 7 x plus h plus 3. So we plugged in x plus h. And what was step 2? Minus the function, because if you don't subtract that, you're not going to get the canceling out. The third step is put it all over h. If you don't want to write that, fine, just put it in at the end. All right. And then this is just a big bunch of distributing. You're going to get 4x squared plus 8xh plus 4h squared. And then minus 7x minus 7h plus 3. And then you just negate all of the rest of it. Which again, that's what causes the canceling out. Once you get there, once it's expanded, a lot of stuff should cancel. If you've done your job right, a lot of stuff should cancel. So do you see anything that's going to cancel? All right, 4x squared. All right, 7x, negative 7x. And the 3s. How many terms are left? 3, and they all have h. So you're going to factor out the h. That will leave you with 8x plus 4h minus 7. Now, if you weren't writing over h, this is where you bring it back, because the point is they cancel and this is your answer.